problem 4 of my Math 420 Advanced Calculus Exam 1 Superset. Prove or give a counterexample. Suppose that there exist two sequences, a sub n and b sub n, such that the limit of a sub n equals L1 and the limit of b sub n equals L2, which is not equal to 0. Then the limit of a sub n divided by b sub n is equal to L1 over L2. So, we're going to start this one. Proof. So suppose that the limit of a sub n equals L1 and the limit of b sub n equals L2, which is not equal to 0. We want to show for epsilon greater than 0, there exists an n that's an element of the natural numbers such that for all little n that are greater than or equal to cap n, a sub n over b sub n minus L1 over L2 is less than epsilon. So let's do a little bit of algebra to try to get this absolute value into something we can use. So we have a sub n over b sub n minus L1 over L2, and we can add 0 to this. So let's subtract L sub 1 over b sub n and add L1 over b sub n, and then that's minus L1 over L2. So then with a little bit more algebraic manipulation, you get a sub n minus L1 times 1 over b sub n plus L1 over L2 times b sub n times L sub 2 minus b sub n. So then we're going to use the triangle inequality to say that this is less than or equal to 1 over b sub n times the absolute value of a sub n minus L1 plus L1 over L2 times b sub n times L2 minus b sub n. Now this part isn't exactly in the format that we'd like, so because it's an absolute value, we can go ahead and switch the order since the absolute value of their difference is equal either way. So now this is b sub n minus L2, and this was by the triangle inequality. So let's talk a little bit about b sub n. Since b sub n converges to L2, at some point the absolute value of b sub n is greater than or equal to L2 over 2. And so conversely, 1 over b sub n is greater than or equal to the absolute value of, 2 over the absolute value of L2. So then we're going to use this to rewrite again. So we had 1 over b sub n times a sub n minus L1 plus L1 over L2 b sub n times b sub n minus L2. And that guy is less than 2 over L2 from substitution times the absolute value of a sub n minus L1 plus, and it's more substitution, we've got L1 and then 2 there, and now this is L2 squared times b sub n minus L2. So this is looking good so far. Next, we're going to talk about a sub n. So since a sub n converges to L1, for epsilon 1, which we're setting equal to epsilon times the absolute value of L2 over 4, which is greater than 0, there exists an n1 that's an element of the natural numbers such that for all little n that are greater than or equal to n1, the absolute value of a sub n minus L1 is less than epsilon 1. Similarly, since b sub n converges to L2, for epsilon 2, which we set equal to epsilon over L2 squared divided by 4L1 greater than 0, there exists some n2, which is an element of the natural numbers, such that for all little n, which are greater than or equal to n2, b sub n minus L2 is less than epsilon 2. So this stuff is super useful because now we're going to do some substitution. So we're going to let n equal the sup of n1, n2. Then for all little n's that are greater than or equal to big N, we have 2 over absolute value of n1 times a the n minus L1 plus 2 L1 over L2 squared times the absolute value of b sub n minus L2. And that's less than, here comes the substitution, 2 over absolute value of L1 times epsilon 1 plus 2 times absolute value of L1 over L2 squared times epsilon 2. So that's equal to, if we plug stuff in, 2 over the absolute value of L1 times epsilon times this up here is supposed to be L sub 1. No, this is supposed to be L sub 2. I had it right the first time. Okay, so this is 2 over the absolute value of L sub 2 times epsilon absolute value of L sub 2 over 4 plus 2 times the absolute value of L1 over L2 squared times epsilon times L2 squared over 4L1. So you can see the stuff cancel, right? L2's gone. 1, L2's gone. And then you have a 2 over 4, so 2. And you get epsilon over 2 plus epsilon over 2, which is equal to epsilon. So that means for all n, which are greater than or equal to cap n, the absolute value of a sub n over a sub b minus L1 over L2 is less than epsilon. Therefore, the limit of a sub n over b sub n is equal to L1 over L2.